There are two different ways that we can use Excel in carrying out our statistical computations. One of them is to work with the data and the equations, and basically to use Excel to carry out the steps of the calculations the same as we would do if we were punching all of the numbers in with a hand calculator. This is slower and more tedious, but it will let us use every equation that we need to have for the entire course. So especially when we get to some of the later equations, there are features that are available in Excel on the Windows computers that are not available on Mac computers. So those of you who have Mac computers will be carrying out the equation method for the entire course, or at least for the places where those functions aren't available. Those of you with PCs will have some options as we go along. In this early stage for the variance and the standard deviation, we have functions available on both platforms. So I'm going to show you how to carry out the step-by-step method first using Julian's data, and then the much faster and more direct functions method using Delia's data. And you can see here on the screen I copied in our equation for the variance. Both of the versions of it, for the sample or for the population, have the same numerator. From each score we subtract the mean, we square those results, and we add them up. We do that regardless of whether we're dealing with a sample or with a population. The difference comes at the last step. If we are dealing with a population, we would use n. If we're dealing with a sample, we use n-1. And that n-1 is an adjustment because the sample tends to underestimate the population parameter. So when we're using it as an estimator, we need to make that adjustment. So let's see how we can take this equation and translate it into a series of Excel steps. You can see I've already typed in Julian's 20 quiz scores, and the first thing I'm going to do is select that full range of scores and give it a name. I'm a big fan of using what Excel calls named ranges. The first thing that's good about them is it makes it nice in typing the equations. I can refer to something that lets me know by the concept what I'm dealing with. The second thing is it's very easy to make an error. Right now I just correctly dragged over all 20 scores, but if I was going really too fast I could drag and go on to the next step and not notice that I had missed the last score down there at the bottom. And in fact, some really famous economists made a mistake exactly like that when working with world data, and a whole raft of public policies were based on erroneous conclusions, and it wasn't until somebody tried to replicate their findings and could not do it that the basic little Excel error was found. So when I take the time to do a careful selection once and then name it, I'll be able to refer to it over and over again. So once I've got it selected, I go up to the left, I type in Julian, and the way to make sure the name is captured by Excel is to hit enter. If I just go back to the spreadsheet and click on one of the cells, the name will not be captured. So I hit enter, my name is captured. I now can refer to the cells for several different calculations. Today we're only going to do the variance. So the first thing I'm going to need, once I have all the scores, in looking at this equation, I have to subtract the mean from every score. So the first thing I do is compute the mean, which in Excel is called average. So I type an equal sign to let it know that I'm doing a computation. I type the name of my function. Here it's average. Then I open a parentheses and I enter what's called the argument. The argument means what do I apply the function of average to. And in this situation, I'm going to apply it to Julian. And notice that as soon as I've typed that name, the selected cells light up. So Excel is letting me see exactly which cells the function will be applied to. So if I've somehow forgotten my name or named something incorrectly, I can tell whether I've got the cells I intend. In this case I do, so I close my parentheses, I hit enter, and there is my answer. 15 is Julian's average. The next thing I need to do is subtract that from every score, so I've created a column in which I can just put the average and copy it many times. So I'm going to click on the place that has the average. I use Control and C on a Mac. It would be Command and C to copy the score. And then when I go up to the top, I'm going to use my right-click button, and you can see there's a variety of different paste options, and the second one says paste values, and that's all I want. I don't need to have the little green thing that I put to mark out that I was doing a computation, not a score. So I'm going to put in, paste the values, and then I'm going to drag all the way down, and it fills down for 15. Some of you may find that your computer will add a number, so it will go 15, 16, 17, etc. In the options, the options that show up here, you can turn on or off that feature. I find that I hardly ever want something to increase every time I'm dragging over it. If you had that situation and you dragged down and the numbers were increasing, once you've dragged over that region, if you hold down Control or Command and type D for down, it will take your top score and fill it down. So now that I've got the mean next to every score, I'm going to do another calculation. So I put in equals, and I click on the cell that has the score. I'm basically copying this part of the equation, so I want the score minus the mean. So I clicked on the score, I type a minus sign, I click on the mean, and I hit enter, and it took 16 minus 15 and computed 1. And again, when I drag down, it will just fill in that equation, but make it apply on each line to the score that's on that line. So it computes for me the deviation score for each of Julian's original scores. In the equation, I need to have those deviations squared, so I've created a column to do that, and you can see I've put in at the head what part I'm using out of the equation. So here I give an equal sign to say that it's a computation. I click on the deviation score, I put in an asterisk, which is for multiplication, and click on the deviation score again. Squared means that I multiply something by itself. I double check to make sure it looks good and hit enter, and it's squared 1. Obviously I get the same number, and just as before, if I drag down all the way to the bottom, it will take every single one of those numbers. So 2 squared was 4, minus 2 squared is also 4. You probably remember from the video lecture that we're squaring the differences in order to get rid of these negative numbers. Without the squaring, they would all add up to 0. So now I have, for each score, the deviation score, and it's been squared. The next thing I need to do is sum them all up. To name this region first, so I've dragged over it. I'm going over and I'm going to call it J for Julian, SQD for squared, or SQ for squared, and put DEV for deviation. So I've got Julian squared deviation as a name. I hit enter, and so now I can put equals sum of Julian squared deviation. Notice how it all lights up, and then close my parentheses and hit enter. So now I have what's often known as the sum of squares, which stands for sum of squared deviations. I really encourage you to memorize that phrase because it tells you the equation. It says we create deviations, we square them, and we add them up. So if you can remember SS, sum of squared deviations, you can actually reconstruct the top half of the equation just from the steps of those words. So I've got my two versions of the equation, one for a population and one for a sample. I've computed the numerator. To get the entire variance, I put in equal to say that I'm doing a calculation. I click on the sum of squared deviations for my numerator. I put a slash for a division sign, and then I need to put in n, which is 20. I know that Julian had 20 scores. I could use a count function if the number of scores was so large I didn't know it by heart, but here I do know it, so that's okay. And when I hit enter, I'm going to get the result of my variance using the population equation. I can do a similar thing. I type equals, I click on my sum of squared deviations from the mean, I put in a division sign, and this time I put in 19 for my n minus 1. And you can see that when I made that adjustment for a sample, it did exactly what the textbook said. We boosted the variance, it's a little bit larger. If I wanted the standard deviation, you can remember that that's the square root, and SQRT is our function. So the square root of the variance for a population would give me the population standard deviation. And I can use the same thing, the square root function, and click on my sample. And you'll see again it's a little bit larger when I'm using the sample equation. So this would be my sample standard deviation. So as you can tell, it took a bit of time, partly because we were talking it through, but this is how I can translate an equation into a series of steps in Excel. In contrast to Julian, when we compute Delia's data, we're going to use Excel's built-in functions, and we're going to look at the standard deviation and then at the variance. You will be amazed how much quicker this is to deal with. So just as I did with Julian, the first thing I'm going to do is name this range of cells. So I've selected it, I go up to the left, I type Delia, I hit enter to make sure that the name is remembered. So now I've named the set of scores by that name Delia. I've put the equation that I'm going to use off to the left so that you can see it on the screen. The equal sign lets Excel know it's a computation. STDEV is the function for standard deviation. When it has .p, it's using the population equation. When it has .s, it's using the sample equation. And then I will put the argument, in this case the word Delia, in parentheses. So all I'm going to do is type that in, my equals sign, my actual function, stdev.p, and then my name, Delia. Notice how the cells light up. That lets me know I've got the right things. I close my parentheses and hit enter, and there, no other computations, just asking for the function. It did the standard deviation. And you might remember from the lecture videos that Delia was the student who had a wild variation in her scores, so it's not surprising to see that her standard deviation is large. I can do the same thing for the sample version of the standard deviation. So I've got stdev.s. I put in the argument, which cells does it apply to, that's Delia, and hit enter, and there is my standard deviation for the sample. And again, you can see it's a little bit larger because we're using that n-1 equation. So you've seen how we can use Excel to translate an equation step by step into an answer, and also how we can use the built-in functions when we have the one that matches our need. This should be enough to get you ready to do the homework that goes with week 2 in our course. Good luck!